Hello everyone. Today we are going to study about transformer. Transformer, we can study its principle, construction, working, its types, losses in transformer, and so on. So let us start. First of all, we'll see what a transformer is. Transformer is a device that changes AC electric power at one voltage level to AC electric power at another voltage level through the action of magnetic field. There are two or more stationary electric circuits that are coupled magnetically. There are two types of transformers, step-up transformer and step-down transformer. Let us see step-up transformer. Step-up transformer converts low potential to high potential. In this type of transformer, number of turns in secondary coil is greater than the primary coil. Here, a simple diagram of transformer is shown and we can observe this is the primary coil whereas this is the secondary coil. Okay, the number of turns in the primary coil is less and is denoted by NP. The number of secondary coil is more and it is denoted by NS. So this is the case in step-up transformer. What? Number of turns in primary is less and number of turns in secondary is more. Let us see step-down transformer. Step-down transformer converts high potential to low potential. And in this kind of transformer, the number of turns in the primary coil is greater than the number of turns in the secondary coil. So this is the basic difference between the step-up transformer and step-down transformer. See, this is the primary coil. This is the secondary coil. Number of turns of a coil in primary is more as compared to number of turns in secondary. Now we can see that transformer is classified depending upon the winding and the voltage level at which the winding is operated. So in case of step-up transformer, just now we have seen the number of turns of primary coil is more as compared to number of turns in secondary coil. So here in this case, primary winding is a low voltage winding, whereas in step-down transformer, primary winding is a high voltage winding. Now let us see the principle of transformer, or we can say on what principle the transformer works. The basic principle on which transformer works is Faraday's law of electromagnetic induction or mutual induction between two coils. In our earlier lectures, we have seen what is Faraday's law. Even we have seen what is mutual induction. So, what the Faraday's law or the mutual induction states is whenever the magnetic flux linked with a coil changes, an EMF is induced in the neighboring coil. So, once again, I'll repeat, whenever the magnetic flux linked with the coil changes, an EMF is induced in the neighboring coil. So this is the principle on which transformer works. Now we see in short how the construction of the transformer is. It is consisting of a rectangular core of soft iron. You can observe a rectangular sheet is there, and huge number of rectangular sheets are kept close to each other. Okay, they are the laminated iron cores. Okay, and this side a primary coil is wound up on this iron core, as well as on this side the secondary coil is wound up, so that it avoids the leakage of magnetic flux and are well insulated from one another. Primary and secondary windings, will try to understand. A two winding transformer consists of two windings, primary and secondary. They are interlinked by a mutual magnetic field. Primary winding, it is energized by connecting it to an input source. You can observe over here. This is the primary coil, and this primary coil is connected to an AC source, and this coil is energized by this AC source. Whereas the secondary winding, at this winding, electrical load is connected, and from which output energy is drawn through these 2 points. Okay, now we'll see how the transformer works. So let us again go with this diagram. Here what we had done, the primary coil is connected to a AC signal. Okay, and when an alternating voltage is applied to this primary coil, the current through this coil goes on changing, due to which magnetic flux is linked with both the coils, and an EMF is induced in each coil. The amount of magnetic flux linked depends on the number of turns of the coil. If number of turns are more magnetic flux will linked, and more amount of EMF will be induced. So on this basis, transformer works. Now we can say that how efficient our transformer is, and we can define the efficiency of transformer as the ratio of power output to power input. So we can write eta is equal to power output upon power input, and power output is nothing but power input minus losses upon power input. So we can say that it is nothing but 1 minus losses upon power input. Usually the efficiency of a power transformer is between 0.9 to 0.99. The higher the rating of a transformer, the greater is its efficiency. So now finally we are going to discuss the losses in the transformer. The losses that occurs in transformer have to be accounted for in any accurate model of transformer behavior. So first of all, we'll see copper losses. Copper losses are the resistive heating losses in the primary and secondary winding of the transformer. They are proportional to the square of the current in the windings. Another loss is the eddy current loss. Eddy current losses are resistive heating losses in the core of the transformer, and they are proportional to square of the voltage applied to the transformer. One more loss is there, that is hysteresis losses, and these hysteresis losses are due to the rearrangement of magnetic domains in the core during the half cycle. They are a complex nonlinear function of the voltage applied to the transformer. One more loss is there, and that is the leakage flux. The fluxes which escape the core and pass through only one of the transformer windings are leakage fluxes. These escaped fluxes produce a self-inductance in the primary and secondary coils, and the effect of this inductance must be accounted for. With this, I stop here. Thank you.